All right, we're going to talk about 2.5 scatter plots today. Our first thing we're going to talk about is our essential question: how are graphs used to interpret data and make predictions? Again, we talked about the two examples I know I've talked in class about your investment for your retirement fund, your investment brokers, or you yourself, if you're handling your money for investment, kind of using that data to make predictions on graphs. The other thing is premiums for health insurance, making sure you guys are making sure that health insurance agencies are going to use it to calculate premiums based on how many people are going to the doctor, what they're spending, that data going up and down. Essential question number 2, parent functions being used to graph new equations involving data. We'll talk about that when we get that to 2.7. Our learning target is using scatter plots to make prediction. Our first vocabulary word is scatter plots. So first word, like I said, was scatter plot. It's a graph that shows how much one variable is affected by another. Again, that should be 1. So it's a graph that shows how much one variable is affected by another. Again, my handwriting's not going to be super great on here, so use the words. Graph that shows how much one variable is affected by another. Next term, line of best fits. Line of best fit is a straight line that best represents the data on a scatter plot. Again, straight line that best represents the data on our scatter plots. Next, we have an outlier. That is a data point that is different from the rest of the data. So an outlier. Data point that is different from the rest of the data. Data point that is different from the rest of the data. So scatter plots, they have 4 types of correlation. First type is strong positive, meaning it's going in a positive direction. The data is all close to one another. Strong negative, again, data point is close to one another, going in a negative direction. The last 2 we have are weak positive. Again, it's going still in an upward direction positively, but the data is more spread out. Weak negative, going downward, but the data is spread out. You could also have no correlation, which means that the data isn't going in any trend. You can see here that the data is making a big circle. It's not going downward, it's not going upward, so therefore we call it no correlation. So let's flip it over to the next page, and we are going to talk about how to use line of best fit and how to do problems. So our problem states a doctor feels that he can accurately find the height of a male at a certain age by plotting several heights and years on a scatter plot. The data in the table shows the age in years and the corresponding height in inches for a male from the age 2 to the age of 19. There's our chart. First thing we need to do is construct a scatter plot. Make sure we label our axis. So let's scroll down to our graph, and let's start by labeling our axis. So on our x-axis, our bottom, we have our computer's a little bit behind. We have our age. And over here, we have our height. So age and height. And we can label our x-axis. We are going to go by 2's. So we're going to go by 2's on our x-axis. So starting here, we have, gotta get the pen. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, all the way to 20. Again, this was our age. Over here we have our heights. We're going to start by drawing our squiggly line, so our break in our graph, so then we can start here and go by 5 starting at 20. So we have 20, 25, 30, 35, and that was 30, 40, 45, 50, 55, 60. And this was 60, so we have 65 up here. This is 70. And finally 75 up here. So next thing we need to do is we need to plot these points, and I'm going to plot them in red. So first point that we need to plot is 2/28 over 2, halfway here, so that would be 2/28 would be right there. 3, 33, 6, 40, 8, 46, 10, 52, 12, 55, 14, 61, 15, 64, 17, 70, 18, 72, and 1972. That should be up a little bit higher right there. So there are our points. So now we want to draw a line of best fit, and I'm going to do that in green for you. So you can save these, so we'll have these in green. When you're drawing your line of best fit, you want to have as many points to the left as to the right of your line of best fit. So again, I'm going to draw mine probably right through there would be my line of best fit. And if you notice for us, it intersects these 2 points. So 640 right there, and it also intersects 1770. So because those 2 points are on the line, we're going to use that to write an equation of our line of best fit using 2 points. Again, you should try to get as many points to the left as you can to the right on your line of best fit. So now let's do number 3, write an equation using line of best fit of the points. First thing I need to do is find my slope. So again, I use my point 640, 1770. I took x2, which is 70, minus x, or y2, which is 70, minus y1, which is 40 to get 30. Took x2, 17, minus 6, which is x2, x1, and I got 11. So I calculated my slope as 30 over 11. I'm going to use this point. So right here, these points to plug into my point-slope equation, and then use that to write it in slope-intercept form, which I'll show you now. All right, so I did this. I took y minus 40 equals 30 over 11, x minus 6. Again, I talked about it. I used 6 and 40 to put this in point-slope form. 30 over 11 was my slope. I then distributed this 30 over 11, so I got y minus 40 equals 30 11ths x minus 180 over 11. I added 40 over, as you can see over here, and this 40 became this 440 over 11. So then I simplified that to y equals 30 over 11x plus 260 over 11. And from there, I wrote it in decimal form, which is y equals 2.73x plus 23.64. Again, I know I did that fairly quick, but you can rewind, fast forward to make sure you're getting that work. Number 4, use the equation to predict how tall somebody would be if they are 23 years old. So we're going to use this equation, y equals 2.73. In place of x, we are going to put 23 because that's our age. And from that, we're going to plus 23.64. So that would be y equals, when I multiply 2.73 times 23, I am going to get, so I take 2.73 times 23, I'm going to get 62.79 plus 23.64. And if I add 23.64, I would get 86.43, which I am going to round to 86 inches. We're labeling it because we're going in inches. Number 5 would be state the correlation, positive, negative, none. What does this mean? Again, if I look at this and flip back over and look at my correlation, it's going up. The data points are fairly close together in my estimation. So I would call this strong because the data points are in positive because they are going up. And what does this mean? And what it means, so again we said a strong positive slope. What does this mean? Your height increases with age. Again, important things to keep in mind when we did this. When you are drawing your line of best fit, make sure you try to get as many points on the left side as the right side. And then when you are calculating your line of best fit, pick 2 points that are on that line, such we did. All right, you will now be getting, you should get a handout. This, you're able to do this on your calculator. That green sheet you got today or will get today, I'll show you how to do this on your calculator. Again, that's just an extra resource, but for today you should be doing these all by hand. Bye.